In this video, I will demonstrate high-level and register transfer level design with our tool Syntagate, a product of Synthesa company. As an example, we will discuss the design of a game called Reversi Atella. Atella is a two-player game on an 8 by 8 square grid with pieces that have two distinct sides. The pieces typically appear coin-like with a light and dark face, each side representing one player. The goal for each player is to make their color pieces occupy the majority of pieces on the board at the end of the game by turning over as many of their opponent's pieces as possible. You can find the link to the rule for this game in PDF script of this video. Let's begin the design. It is our working folder before the design. In the beginning we have only folder initial. If the designer would like to use a pre-designed IP core, he should put in the second folder components. In this design I don't have pre-designed cores, so I don't have a component folder. Let's go to folder initial. Folder initial has only one ASM. This ASM was constructed with our GUI ASM creator. You can find more information about ASM creator at synthesa.com, and you can even download it and try it for free. As you see, ASM contains vertex begin, vertex end, and operator and conditional vertices. A Boolean expression can be written in the conditional vertex. An operator with one, two, or more micro-operations can be written in the operator vertex. There are two kinds of micro-operations in ASM. The first kind is a simple micro-operation containing assignment colon equal. The second kind of micro-operation is a component micro-operation. We call it sub-ASM or generalized operator. Such micro-operation doesn't contain an assign operator colon equal. In this example, we are colored yellow, but the color is not essential. These operators are sub-ASM even being included in the mother's ASM to get the whole behavioral of digital system, or one of its modes if you would like to present them separately. We have 5 such sub-ASM in ASM game. Sub-ASM can contain sub-ASMs, and there are no constraints on the number of sub-ASMs and the number of levels of such inclusion. To open such sub-ASM from top to bottom, right-click and select Open. For example, Open, 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 and Open. With generalized operator, we can implement the top-to-bottom design. From a design standpoint, complex ASMs aren't necessary. As a rule, they contain about 7-10 vertices. The designer must put generalized operators in the folder General, which is a subfolder of folder Initial. You can find all of the ASMs in the folder Initial at synthesa.com. Thus, before we design, we have ASD, GSA and TXT files in folder Initial and its subfolder General. Now that I have explained the content of a working folder before we design, we can begin the design of our game. I am opening our small interface to demonstrate the Syntagate design tool. I put the name of working folder in the line project folder of our interface. I checked the box ASM, I begin with ASMs from GUI, and didn't check the box Combine ASM. I have only one ASM in this design. I checked the box Include Generalized. I have several sub-ASMs in folder General, and check the box FuncSpec to construct functional specification. To design the game at the high level and RTL, I must click Run. And immediately Syntagate suggests that I construct functional specification in the dialog mode. In this design, Syntagate asked me only one question. And I insert 64 and click Finish. And In about 4 seconds, the design is complete, both at high level and the register transfer level. As a result, we have 14 new folders in the working folder. Each folder contains one or several stages of the design together with complete documentation for these stages. First, the special Syntagate program automatically creates a folder spec, an XML code of the functional specification, file funcmi spec in this folder. This file contains specifications of 8 ports, 20 signals, and 1 variable. And Syntagate required only one input field. The result of high-level synthesis is presented in folder HLS. Syntagate automatically constructs two designs at the same time. The first in VHDL, funcmi VHD, and the second in systemc, file funcmi CPP. File funcmi VHD is a finite state machine with 70 states and 728 lines. This FSM presents our whole design at the high level in VHDL. File funcmi CPP is a little bit longer. It has 961 lines with the same 70 states, and it also presents our design at the high level in systemc. After preparing a test bench, the designer can simulate the functional project with any simulation tool. The designer must choose what they would like to use at the simulation at the high level, version in VHDL or version in systemc. The same test bench can be used at the last stage of the design at the RTL level. I will return to this simulation a bit later. Now let's look at the RTL design. In the folder RTL, Syntagate generates VHDL codes for 14 components of a data path listed in file components VHD. 1 bore, 5 muxes, 1 ALU, arithmetic logic units, 3 counters, 2 register, 1 RS flip-flop, and 1 comparator. At the last step of data path design, Syntagate automatically instantiates these components in the data path file dp VHD. In this folder. At the bottom of this file, you will find that it contains 378 lines and 46 components instantiated in the data path. The number of instantiated components is more than the number of VHDL files in folder RTL because some components are used several times. Syntagate automatically creates the RTL code of control unit. File structem VHD. Its input signals are feedback from data path and some inputs of a digital system. Its outputs are micro-operations with several implemented in the data path and several outputs of a design system. The control unit is a finite state machine with 86 states and 185 lines. At the last step of design, Syntagate creates the top level, file top VHD, automatically combining two components, the control unit and the data path. The entity of this file contains inputs and outputs of the design systems. Its architecture has two components, the control unit, structem, and data path, and with signals connecting these components and instantiation of these two components, U1 FSM and U2 DP. Now let's talk about the simulation of the game. To begin the simulation, I prepared the folder simulation with two subfolders, HLS and RTL, for simulation at high level and Redis transfer level. I am moving this folder into a working folder dvideo5 Atella. We have here folder for HLS simulation and RTL. That is, benches at HLS and RTL are equal. I gave them different names so you can compare them. The only difference is in the names of the entities, architectures and components. I want to mention high-level synthesis uses the package mypackage.vhd and RTL uses package components. Both these packages were constructed automatically. I won't take your time by showing you this simulation. You can do that yourself with any simulation tools. Once again, we have implemented the design containing 269 files in about 4 seconds each. And at the beginning, we only had algorithmic state machines and nothing else. No VHDL, no Verilog, etc. You can find more about the design methodology realized in Syntagate in my books, Finite State Machine and Algorithmic State Machine, and High-Level Synthesis of Digital Systems, available on Amazon in ebook and paperback. Thank you.